welcome grade 10 and even grade 9. This is the introduction to exponential equations, which you might have learned last year, right? But we're using it as an introduction to grade 10. So we have exponential equations, and they are called such because our variable is in the exponent. Okay, so instead of having 2x, instead of having something like 2x equals 4, right, where x is over here, your x is now an exponent, right? And they are treated very, very differently because 2 multiplied by x is not the same as 2 raised to an exponent x, because in this case we are saying what 2 is being multiplied by, but in this case we are saying how many times is 2 multiplied by 2, right? So we cannot treat it the same way that we treat linear equations. Instead, these equations are all about the base, okay? No treble, because once we have our bases the same, it becomes very easy to see what your solution is, okay? So at this point, 2 exponent x equals 8 does not look like something nice to solve. One way to solve it is by taking 2 and raising it to different values of x. Let's try 1 and checking which value produces 8. So when x is 1 it doesn't work, when x is 2 it doesn't work, but when x is 3 it works. So by means of substitution and elimination, we see that our solution to this specific equation is when x is equal to 3. Okay, there's no question about it. We saw it happening. Our equation works out when x is 3. So now I'm going to show you mathematically how to get to that answer, right? And like I said, it's all about the base, and that is the key. So we got 2 exponent x equals to 2 exponent 3. So we take our 8, right? We press equals shift fact, and 8 can be expressed as 2 raised to the third exponent, right? So instead of having 8, we have 2 exponent 3, and at this point we focus on the exponents. It's now not about the base anymore, it's now about the exponents. Okay, for those of you that like to watch crime documentaries or series with cops in, we're doing a B and E. We focus on the base and then we focus on the exponent. So now we can see if the stuff on the left is the same as the stuff on the right. We have the 2's, so that means that this here must be equal to that there, and so therefore x equals 3, and we knew that already. So that is the solution to our first equation. Alright, we add one level of difficulty to our sum. We have our exponent over there, right? This exponent is attached to this 3, it belongs to that 3, right? There is no getting rid of this 3, but we can get rid of that 3, and so that is our very first step. Our very first step is to get rid of that 3. So I'm going to take my expression, my equation, divide it by 3 on both sides. So I go 9 over 3, right? Of course we can cancel this 3, so I'm left with 3 exponent x equal to 3. Okay, let's go make that a fraction. At this point, it's all about the base, but my bases are the same. Okay, but now it appears as though this 3 has no exponent, but you guys are too smart to be tricked by something like this. Okay, because the exponent in actual fact over there is a 1. So now at this point, we did our B and now we go to our E. My exponent tells me that x is equal to 1. Classic B and E done by you and me. MME, x is equal to 1, and that is the solution. Now before we conclude this example, I want to be dead certain that my answers are right. So according to our calculations, when x is 1, the value on the left is 9. Let's see. Is 3 multiplied by 3 exponent 1? Apologies for that. Is 3 multiplied by 3 exponent 1 going to give us 9? Yes, it is. So that means our solution is correct. Easy. I would like you to try the following questions. Once you have the solution, type it in the comments and I will like your comment